Hello, I am 19. If you're watching this video, you're watching problem 2 of section 11.2. We're still in chapter 9 and 11, which is regression of data. So go ahead and pause the video and create your scatter plot. I created mine to make this video a little bit faster, but the table below shows the median price of a single family home in the US from 2000 to 2010. Go ahead and create your scatter plot. It's okay if you label your y-axis to go by thousands. So if you take a look at mine, I went up about 25,000 between each on the range. So go ahead and create your scatter plot. Okay, so let's go ahead and answer question number 2. What do you notice about the median price of a home from 2000 to 2010? Sketch the line of regression and which function family is best represented. Well, if you take a look, in 2000, the price was pretty low. It was only 122,000, and then all of a sudden it starts to increase and increase and increase, hits a maximum, and then starts to decrease again. So there's a change in direction of your graph. I'm going to go ahead and sketch the line of best fit for this scatter plot. Well, this function family is the quadratic function family. It forms a quadratic graph. State the domain and a range of the problem situation, so that's referring to our table and our exact data, and also for the function, which is the line that I drew. It's the line of best fit. So let's cut number 2 into 2 different pieces and name the domain and range for each part. The domain for the problem situation refers to your year numbers. Okay, so how long you looked at data in your years. So we looked at data from year 2000 to 2010. The range is the price of the home. Well, the minimum price of the home was around 120,000, so $120,900 up to $169,200. That was the range of our particular data. The function refers to any possible year number. Okay, so we could go back in time to predict the price of homes. So this would be all real numbers. Because we can include any year number. And the range is any price of a home. So this one is actually all real numbers greater than 0. You can't have 0 for your price of your home. Does your function have an absolute min or max or neither? Well, we see here that our graph initially increases from when we started in year 2000 and starts to decrease. So that change in direction of your graph creates an absolute max, which means that was the maximum price of the home during our data, which happened to be around what looks like year in 2005. That was the maximum price of our home. So 2005, so we need a comma here, 2005, comma, $1,690, $200. So in year 2000, that was the maximum price of the home. Create your equation. Just like we did in previous problems, you would enter your year number into L1, and you would enter your price of the home into your L2, and choose the quadratic regression equation. The same, you create the equation the exact same way you would create your linear equation or your exponential. So you substitute in your values for A and B and C. This one has 3 different variables. So I'm going to go ahead and write the equation for you. You should really try to calculate this yourself. So y equals a long equation. Let's answer number 6. Use the function equation you created to answer each question. Question A says predict the price of the home in year 1999. So if we started collecting our data in 2000, year 1999 would be 1 year in the past. So x would be -1. So you would take your -1 and substitute it into your formula wherever you see an x value. So I have it shown here and here. You can type all of that into your calculator. The answer was $90,542.19. So that was the predicted price of the home in 1999. Let's do another one. 2011. Okay, so you have to figure out how much time has gone by. It's been 11 years, so you substitute 11 into your equation, just like you did for part A, and calculate the answer. The answer was $102,416. Let's go to part C. And predict the price of a home in year 2015. The X was 15, Y equals -$7,725.81. Well, that solution does not make sense because you can't pay less than $0 for your home. So with this type of regression on this equation, they're predicting that homes would be essentially free by year 2015 because you can't go below 0. Go ahead and try the homework that is included in your packet for this unit.